So percent yield is always actual over ideal or theoretical. Now, and times 100, okay? So actual is what we actually get through experimentation, what we actually have. Ideal is what we expect to get by our calculations. And 99% of the time, you are not gonna get 100% yield. And if you get a more than 100% yield, you obviously did something wrong, because there's no way that you get 200% yield, right? It's kind of like saying, you know, somebody tells you that, hey, you give me $5 and I'll double your money, right? In a day. Don't worry about it, I'll double it, you know?
It's not, I'm not sure.
What was that?
I'm talking to myself.
Okay, so percent yield is always going to be less than 100%, okay? If it is more than 100%, that means that you probably done something wrong, or you probably put your ideal on top and your actual on the bottom, which is not what you want to do, okay? And that makes sense, right? Because the best you can do is what? What is, in terms of percent yield, what is the best percentage you can have?
100.
100, right? So if your actual is greater than your ideal, then you know you've done something wrong. Simple?
Yeah.
Now you want to try to test it out, right? Come on, we're in the last rings. You should be excited about this. Okay, so we have a solution containing 3.18 grams of barium chloride is added to a second solution containing excess sodium sulfate. Barium sulfate precipitates. Calculate the yield of the barium sulfate. If the actual yield is 3.37 grams, calculate the percent yield. Okay, so what is the first thing that we want to do?
Take our given.
Well, we can take our given, but it isn't going to do us any good unless we do something else first.
You want to do the equation
Do the equation and balance the equation.
and balance the equation.
So we want a chemical equation and we want it to be balanced. Okay, so what are my reactants?
Barium chloride and
Sodium sulfate.
sodium sulfate.
Okay, so what is barium chloride? What is the chemical formula for barium chloride?
BaCl2.
Oh, barium BA.
Cl2.
Okay, was that aqueous? Was it liquid? Was it solid? Was it gas?
Aqueous.
That one's a solution.
So aqueous. Is that what you're telling me? Okay, what is my other reactant?
Sodium sulfate.
Okay, what does sodium sulfate look like? What is the chemical formula for sodium sulfate?
Na2SO4.
Solid, liquid, gas, or aqueous?
Solid.
Aqueous.
Yeah. Solution.
Aqueous.
Aqueous. And it yields, what are my products?
Barium sulfate.
Barium sulfate
Sodium chloride.
and then sodium chloride.
And barium sulfate looks like what? What is the chemical formula for barium sulfate? BA.
SO4.
SO4.
BaSO4.
SO4, yeah.
Oh, then I.
Is that solid, liquid, gas, or aqueous?
Aqueous.
Are you sure?
No, it's solid.
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 And how do we know it was a solid? Other than me saying, are you sure?
Persistent. Cancel it.
There we go. Okay, and the other product is?
NaBA.
Sodium chloride.
NaCl, solid, liquid, gas, or aqueous?
Solid.
That's the
Are you
A.
sure?
Aqueous.
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 It's going to be aqueous because, well, something in chapter 9, but also because we didn't tell you it was a precipitate. Okay, is it balanced?
No.
What do I need to do to balance it?
We need 2 sodiums and 2 chlorines in the product side.
So 2 sodium chlorides? Is that what you're saying?
Yeah.
Okay, so we want a coefficient of 2 in front. Is it balanced now?
Yeah.
Yes.
Piece of cake? Okay, so now, Megan, what do we do next? Is she ignoring me now? She's like, you didn't want me earlier
I'm
now.
Sure now.
Given.
I guess we take our given,
Take our given. So our given is what?
3.18 grams of barium chloride.
3.18 grams of barium chloride. Oops. Okay, and what is it that we want?
We want
Barium sulfate.
So we want sodium sulfate.
barium sulfate, right?
I'm sorry,
Barium.
barium sulfate. Thank you. Barium sulfate.
Do you need the molar mass of barium sulfate?
We will, but we need the molar mass of barium chloride first.
Molar chloride, I meant, yeah.
So what is the molar mass of barium chloride?
Barium.
208.
Okay. So I believe it's 35.45 times 2 plus 137.3. And then I think if you do the math, it should be about 208 grams per mole. Is that right, Ronky? Did I get it right?
Yes,
208?
sir.
Okay.
We'll give money, please.
Okay, so what am I gonna do with that 208? Other than just look at it, see how pretty it is.
You're gonna plug it into the bottom.
Okay. So that's 208 grams of barium chloride at the bottom. And then what am I gonna put on top?
1 mole of barium chloride.
1 mole of barium chloride. Okay. So that gets rid of grams of barium chloride. We have moles of barium chloride. What is it that we want again?
Moles of barium.
Barium sulfate.
So I need to next get moles of barium sulfate. So how do I figure out the number of barium sulfates that I need?
You find the molar mass of barium sulfate.
On the equation, we
Well,
have,
right now I have moles of barium chloride. So
yeah, then on the equation, you have 1 mole of
Don't you have to find the,
1 mole of barium chloride by 1 mole of barium sulfate.
okay, 1 mole of barium chloride. And then that's going to give me 1 mole
10. Okay. 80.
of barium sulfate. Okay, Megan, now then what do we do?
you find the molar mass of barium sulfate.
Okay, now we need the molar mass of barium sulfate.
230, 233.
233. So BaSO4. What is that? 64 plus 32 plus 137. 3. And you said that was 234. Are you sure?
233.
I said 233.
233.
12 million.
Okay, so on top or on bottom, and that's grams per mole.
Gonna be on
33 grams will be on top.
Isn't that equal to? Well, I know.
So what do you guys get? And how many sig figs should we have?
Three, because you were given 3 sig figs.
Okay, so I should have 3 sig figs. Okay, so what should my answer be?
I need help again.
3.56.
This is my last problem.
Hold on.
3.56.
I'll wait till you're done.
Very full.
I got 3.56 kg.
3.56 or 57?
Yes. 6. 5.6.
Okay. There is no number after that 6 that's greater than 5.
Maybe I missed up.
No, because it's
Mine is 2.
2, so it doesn't.
Okay. I'm just asking. Don't beat me up because I'm questioning you. Okay, so then what's next?
You want to put it into that actual yield over ideal yield.
Okay.
Means 100%.
Actual over ideal times 100.
So what we found was the ideal yield.
That's correct. What you figure out by stoichiometry is your ideal.
Calculator.
Always?
Yes.
Okay.
Doc, please, which one is ideal?
You tell me which one is ideal.
The ideal would be 3.56.
Yes, it's what we figured out through stoichiometry.
Okay.
An actual is what we got via experiment, or what they tell you the actual is. Okay, so what is the actual?
3.37 grams.
Multiply that by 100, and what do we get?
95.
How many sig figs should I have? 3 sig figs?
Mhm.
6 or 7.
Okay, piece of cake.
Somewhat. Sometimes I get lost in the stoichiometry portion, like with the long multiplication and division.
Yeah. The best way of keeping yourself from doing that is following your units that are being crossed out. Make sure that they actually are really crossing each other out.
So, Dr. Harry,
Yes.
I have a question. On the practice test you gave us, the practice one,
Yep.
you asked to calculate, I think, the mass in gram of the precipitate.
Okay.
So we stopped it at that 3.56 gram barium sulfur, right?
Okay. Can you repeat that, please?
So on the practice test,
Yep.
there's one question you ask like this, but it says, what is the mass of the precipitate in grams?
Yep.
So we don't have to, we're just gonna stop it at the 3.56 grams barium sulfate.
That's correct. That's what you would stop it at.
Okay.
Yeah. If I asked you percent yield, I would actually have to give you your actual, what you actually obtain.
Okay.
Okay.
I was going to ask that question. I don't know how to go about it. That
Pardon
big
me?
part. The question the Barry just asked now. I don't know how to go about that question. The big part of it.
You say you don't know how to do it? Was that Rocky? I missed because the shuffling of papers. I didn't hear what you said.
Oh, I'm sorry. I didn't. I missed myself. I'm talking about the big part of the question. What Iberi just asked now. Calculate how much is in gram of the precipitants.
Okay. Yeah. And that's what you're able to do, right? Because once you have a balanced chemical equation, you can use that to sit there and calculate how much the other one is. As long as you know what you're working with, which you should, right? At that point, know what you're working with.
Okay. Just for the what's it called now? Mercury sulfate. Is that one we're getting in gram?
So you said for the mercury sulfate.
That's my precipitant.
Okay. So if mercury sulfate was your precipitant, then how would you calculate that? You'd use a chemical equation.
Yeah.
You would go
I did
through
that.
this. You would do it exactly the same process, right? Exactly the same process. The only thing is that you're working with mercury sulfate. So at the end, you would multiply by mercury sulfate instead of barium sulfate.
Oh, just like this.
Yes.
Okay.
And this is important. This is the thing that, that these are example problems, right?
Mhm.
Yeah. From these example problems, you should be able to sit there and figure out what to do under your particular case, right? I'm not going to give you exactly the same damn problem. And if I do, then I'm probably on crack. Just letting you know. Because you're supposed to be expanding your knowledge, right? And so you need to be able to sit there and apply this example. So that's the reason why you take notes, that you can sit there, okay, yeah. So I need to make sure I follow my dimensional analysis. I need to make sure I do this, right? That makes sense? Yeah, no, maybe? Giselle, does that make sense? Mrs. Nobody else is gonna talk to me. I know Giselle has talked to me.
Yes, it is making
Yeah,
sense.
makes sense.
Hopefully, I will do good on the test when it comes to percentage yield.
Yeah, good, good. Okay,
Wait, this was on the test? Like this exam? Exam 3?
Yeah, it is.
I don't know.
stoichiometry is on the test. Percent yield, I'm pretty sure isn't on the test.
It's kind of like,
Wait. So don't mistake percent yield for percent mass, because they're two different
yeah,
things.
it looks similar.
Yeah, they are kind of similar, but they're a little different, because percent
Yeah.
mass is part of the whole, which you guys should know that, right? Because we've done that at least twice already.
Hope I did mine right.
Okay. Okay, let's see. So my next question. Solid sodium nitrate decomposes to a solid sodium nitrite and oxygen gas upon heating. One set of the reaction conditions gives 95% yield. What mass of sodium nitrite will be produced by the decomposition of 1.5 grams of sodium nitrate?
Is this the same?
Okay, what is the first thing that we're gonna do?
Set up the equation.
Set up our chemical equation. Okay, so what are we gonna do to do that? We're gonna do. Gotcha. What are we gonna do? That still doesn't sound right. To do that, what do we need to do?
Identify our reactants and firsts.
Okay, so what are our reactants?
Solid sodium nitrate.
Okay, what does that chemical formula look like?
Sodium nitrate will be Na. 1 minute. Nitrate.
NaNO4.
No, no. And
And
three.
NaNO3.
NaNO3. Everybody agree to that?
Yes,
Yes.
Yes.
And is it solid, liquid, or gas?
solid.
Okay. And what happens?
It decomposes.
Decomposes.
It
Sodium nitrate
decomposes.
oxygen.
What do you mean by that?
It breaks apart.
It breaks apart to form what?
Sodium
Nitrate and oxygen.
nitrate and oxygen gas.
Okay. What does sodium nitrite look like?
NaNO2.
Solid, liquid, or gas?
Solid.
Okay.
And then plus O2 gas.
Okay. So we have, thank you. Is it balanced?
No.
Nope. Let's see. I have one sodium on both sides. I have one nitrogen on both sides. And I have 3 oxygens on one side and 4 oxygens on the other side. Is that right? Or am I just making stuff up?
That's right.
Okay. So is that balanced? Kabiri said no.
Oh,
Okay,
yeah.
what do I need to do to balance it, Matt?
Okay, let me balance it for you. It's gonna be.
No, I want Matt to do it, Kabiri.
Okay, go ahead.
We could put a 2 on the sodium nitrate.
2 on the sodium nitrate.
Yeah.
Okay, I did that.
And that'll give us 2 sodiums, 2 nitrogens, and then 6 oxygens.
Okay,
And then we'll put a 2 on the sodium nitrate.
okay,
That'll be 2 sodium, 2 nitrogens, and then 4 oxygens. And then
Plus?
that, yeah, plus the other 2, that's 6.
okay. So is that balanced?
Yeah.
Good job. Okay, so now we have a balanced equation. What's next? Megan is always gonna say this. Start with what you're given. What am I given? See, I read her mind. Didn't I read your mind, Megan?
I actually wasn't gonna say nothing, but okay.
You know you were gonna say it. Don't fake it.
No, I
Raina, what am I gonna do with that given? What is my given?
1.5 grams.
I heard somebody say it. 1.5
grams of sodium nitrate.
grams of sodium nitrate. And what is it that I want?
Sodium nitrite, the mass. in
I
grams.
want sodium nitrite. So what? You say grams of sodium nitrite.
Yes.
Oops. Okay. So what is my first step, Jonathan? Are you there, Jonathan? Okay, that's all right. Heidi.
Can I answer?
Go ahead, give me an answer.
To calculate the molar mass of sodium nitrate.
Okay, what is the molar mass of sodium nitrate?
You gotta
Sodium is
22.990.
Oh, can I say just 23?
Yeah, I
And
just
I
don't
have-
know if you want us to round or not. I usually just keep it all.
Okay, that's nitrogen. There's nothing wrong with it. That's good.
14.
14. And I have 3 oxygens. 3 times 16 equals 48. So I'm gonna add all of those together, and what do I get?
Eighty.
It's 85 grams per mole.
Then you plug that in.
Okay, so where am I gonna plug it in at? Top, bottom.
On the bottom. On the bottom.
85 grams on the bottom. And I put my 1 mole on top. And if I remember correctly, this is sodium nitrate.
Oh, wait. It's grams per mole of sodium nitrate?
That's right.
Okay, yeah.
So put grams at the bottom, and then we put moles on top, right?
Oh, yeah. And those cancel out.
Okay, so my grams are gonna cancel out. Now I'm left with just moles of sodium nitrate, and I want nitrite. So what am I gonna do?
1 mole sodium nitrate under on the bottom.
Why 1 mole? But isn't there 2?
It's gonna be two mole of sodium nitrate and 2 mole of sodium nitrite.
Yeah. I forgot about the numbers that we had in the front.
Yeah, you gotta remember those numbers. It just happened to work out well for you here.
Yeah.
Okay, so then that gives me my moles of sodium nitrite. So how do I go from moles of sodium nitrite to grams of sodium nitrite?
Calculate the molar mass of sodium nitrate.
Okay, so I have to calculate the molar mass of sodium nitrite. So if I remember, nitrite is just 1 oxygen less. So if I just subtract 16 from here, would that work? What is that? 69 grams per mole?
Yep.
Okay, so am I gonna multiply it by it, or am I gonna divide it by it, or what am I gonna do? Where's the 69 gonna go?
Oh.
Top or bottom? Tiberi says top.
I agree.
So that means 1 mole goes on the bottom of sodium nitrite. Oops. Okay, so moles of sodium nitrite cancels out, and then I'm just left with grams of sodium nitrite, which is what I want. So what do you guys get?
$1.22 grams.
1.22. Okay, so I got 1.22 grams of sodium nitrate. So then that tells me part of what I want. It says, what is the mass of sodium nitrate that will actually be produced by the decomposition? So is this theoretical, or is this, I'm sorry, is this ideal, or is this actual?
This
Actual.
is ideal.
Deal.
Ideal.
Ideal. Okay, so we know that ideal is at the bottom, actual is at the top. So if we wanted to calculate actual, we know that that is equal to times 100, and that's going to equal my percent yield. Oops. Okay, so in this case, we know that that is 95%. And you just told me that this was my ideal. So this is 1.22 grams. And so actual is up top. So then times 100. So my actual, if I do my algebra, my actual is going to be
95 times 1.22 divided by 100.
okay. And what do you guys get?
$1.16.
Okay. Isn't the prettiest N, is it? Okay. Oops, that should be nitrite. Piece of cake?
Somewhat.
Yeah, this one's okay.
Okay. Everybody got it down?
Yeah, I got it.
Okay. How many of you guys have made grilled cheese sandwiches?
Really?
I have.
Okay, Giselle, since you and Matt are the only two that made grilled cheese sandwiches ever. Okay, so what is the recipe for a grilled cheese sandwich? Basic recipe.
Bread and cheese.
Bread and cheese. Okay, how many pieces of bread do you need?
2.
2.
Okay, so if I have 2 bread plus 1 cheese. That's going to yield 1 sandwich. Everybody agree?
Yeah.
Anybody want to fight me over it?
Well, you need butter, but
Butter
yeah.
makes everything better, right?
Mhm.
Okay, so we're just going to keep it simple for right now. Okay, so if I have 11 slices of cheeses, and I have 28 slices of bread, how many sandwiches can I make?
11.
Why 11?
That's how many cheese you got.
So are you telling me that I'm going to run out of cheese before I run out of bread?
Yeah.
Okay, so in that case, that the cheese is limiting, our limiting reactant, right? We're going to run out of that before we run out of anything else.
Yeah.
And so that means that the bread is excess.
Mm.
You get that?
I see you.
Yeah.
Okay. So how many extra slices of bread do I have?
6.
7.
Okay. I have 6 extra slices of bread. Okay. So, and that makes sense, right? Pretty simple. Not too hard.
Yeah.
Okay. So a limiting reactant is the reactant that is going to be consumed first, right? The stuff that we're going to run out at first. Excess is the one that we're going to have the stuff left over. Not too hard. Okay, so here we have 3 molecules of carbon, and we have 2 molecules, let me see, 3 atoms of carbon and 2 molecules of oxygen. How many carbon dioxide molecules can we make if we put those 2 together?
2.
2. How much carbon is going to be left over?
1 atom.
1. Make sense?
Wait, can you say it again?
I said if we have 3 atoms of carbon and 2 atoms of oxygen,
Yeah.
how many carbon dioxides can I make? And you said 2, right? How many carbon is going to be left over? 1. You guys get that?
Yeah.
Simple, right? And that carbon is going to be left over. There's nothing we can do with it because there's no more oxygen to react with it because oxygen was limiting and carbon was excess. Piece of cake?
Yeah.
Okay, so when you're solving limiting reactant problems, there's a couple of ways of getting to the answer, right? One of them is if you're given grams for both of your reactants, anytime that you're given grams for both of your reactants, that probably means that you have a limiting reactant problem. That's the first thing that you should recognize, okay? The first thing that you want to do is convert both of those to moles. Okay, so once you convert those to moles, that tells you how many moles of each of your reactants you have. Now you want to try to identify which one is limiting. The way that you would do that is by figuring out how many moles of the other guy you need, right? So you have what you have, and you try to figure out what you need. Okay, and then you just compare those two, right? So that's one way of doing it. Another way of doing it is the long way, right? Is by figuring out the number of moles of what you have and then figure out how much product you can make. And the one that gives you the lowest amount of product is the correct answer. Okay, simple. So I'm going to show you the easy way, what I perceive as being the easy way, easier, quick way, compared to the long doing products for both of them. Okay. Okay, so it says calculate the mass of, have no idea why it keeps doing that. Calculate the mass of antimony 3 iodide, SbI3, that can be produced by the reaction of 129 grams of antimony, Sb, and 381 grams of iodine. Also find the mass in grams of the element that will be left. Okay, so what is the first thing that I want to do?
Yeah. Balance the equation.
Balance the equation. So what is my chemical equation going to look like?
Antimony plus iodide equals antimony 3 iodide.
Okay, so we know antimony is Sb plus iodide. What does iodide look like?
I2,
I2. Why is it I2?
because it's a diatomic element.
Good job.
Good job, Alex.
It's because he capped on me last time when I forgot, so I remembered.
Who did? Who would do that to you, Alex?
You, my teacher?
Your teacher? I don't believe that. He never. Okay, is it balanced?
No.
No? What do I need to do to balance it?
Put 3 on the SB. Yeah, wait.
This one?
You should put a 2. 2 to make the I a 6, so then you put a 3 in the iodide. on
The
other
lady
side.
say 2. Okay,
Then you put a 3 there.
3 here.
Yes, and a 2 on the antimony.
Okay, Fabian, do you agree with them?
Yeah, I just messed up on the number.
Okay. Okay, so it's balanced now.
Yes.
Okay, so the first thing that you want to do is what?
Put the given.
Okay, our givens. We have 129 grams of Sb, and we have 381 grams of I2. So what am I going to do with that? Mary,
Yep.
not Iberi. I said Mary.
Oh.
I can say any name, and Iberi's going to say, yep.
He pays attention.
Are you there, Mary?
Hey, at least he responds to you. Not
Oh, I was speaking. That's on mute.
Okay. Okay,
You're
Mary,
gonna
so-
find the molar mass of Sb.
Okay, so what is the molar mass of Sb?
It's 122.
122. So 122 grams of Sb on bottom.
Mhm.
So that means one
And
mole
one
on
more
top.
on the top.
Okay, good job. Okay, what do you guys get? How many sig figs should I have?
3.
3?
106.
Okay, so I'm gonna say these are half.
How do you know that?
Because that's what I have. That's how much I'm given.
I got you. Cab is what you're given.
Yep. Or let me say given. Maybe that'll make more sense.
Yeah.
Okay, now what about the iodine? What's the molar mass of iodine?
127.
But isn't it I2?
127 times 2.
Okay, 254
Yes.
grams of I2.
One 1.5.
3 sig fig, so 1.50.
Yes.
Okay, so these are both my givens, right? So if I have my givens, I can calculate what I need to react with that. So let's do it down here. Let's figure out how much SB do I need to react with 1 point, use a different color. So how would I calculate the number of moles of SB that I need to react with 1.50 moles of I2? So I want moles of SB. So how can I calculate that?
You're gonna put
Would it be 3 moles of I2?
On bottom or on top?
The bottom.
bottom.
And then what am I going to put on top?
2 SB or 2 moles of SB.
Okay, so then that's going to cancel. So then we're left with just moles of SB. And if I remember correctly, this is going to be 1.00. And how much SB do I actually, how much SB am I actually given? This is what I want. Or need. This is what I need. Okay, so my given, and this is how much I need. So what is limiting? Iodine or SB?
Iodine?
Iodine is limiting, that is correct.
Iodine is limiting because it's smaller.
Because if you look at how much it needs, SB that we actually need, it's 1.00. This is how much we actually have, 1.06. So we have 0.06 excess. Do you guys see that?
Yeah.
So if I
Oh, is
need,
it because it's like closer to what we need?
no, it's limiting because it's 1.00 compared to, this is how much we actually have. So we have all of this extra, right? So we have 1.06, that's what our given is. That's how much we have. Because you remember the bread and the cheese, right? The cheese was less, right? We ran out of cheese before we ran out of thing. So if I use all of this, right, all of it, I'm going to need 1.06. That means that I'm going to run out of this before I use up all of this, right? Because I only need 1.00 of that. So that means I have 0.6 left over. Does that make sense?
Yes.
No.
No.
Okay.
Because the other one is
Are you?
less. So wouldn't you?
Okay,
rather
wait.
put
Listen. Okay. So we got to compare apples to apples, right? We have to make sure that we're looking at the same thing. This is how much we're given. This is
But
what
it
we
says-
have to work with. This is what you have to work with. 1.06 moles, right? So if I'm given 1.50 moles of iodine, I'm going to only use up 1.00 moles of antimony. Do you see that?
Yeah.
Okay, but I have 1.06. Man, which one is more than what I need? This amount or this amount?
The one.
It's the 1.06.
The 1.06, because I have 1.06, but I'm only going to need to use up 1.00. And then I'm going to use up all of this guy. It's going to all be gone. There's nothing going to be left, right? So there's still 0.06 left of this one. Go on, Kelsey. It's not, it's just like the cheese, right?
Which one's
Keep going.
cheese? Which one's cheese?
This one is the cheese.
Because you said they're both given.
Yeah, they're both given, right? So in the case of the cheese got used up first, right?
Yeah.
So this guy, if we have 1.00, it's going to take 1.00 moles of antimony to completely use up all of the iodine. There won't be any iodine left, right? But we actually have 1.06 moles of antimony.
Oh, okay.
Oh, okay.
So the iodine is the limiting reactant, while the antimony is the excessive reactant.
Excess. Yes, so this guy is excess.
So it takes 1 point mole of the SB
That's right.
to
So,
use the
yeah.
Okay.
Yeah. So you use up all of this, right?
Right.
By just using up 1.00 moles of antimony.
I got
So
you.
then this guy is excess by 0.06.
Right.
And so if we want to figure out the mass of how much is left over, we just multiply that 0.06 that we just calculated from subtracting 1.06 moles from 1 mole. And that's going to give me my excess.
So the limited is iodide.
That's right.
Where did you get the 3 to cancel out on the bottom? 3 mole of IO.
From our chemical equation.
Oh, okay.
Yeah, you always use your chemical equation to figure out how much of the other guy you're going to need.
Okay.
Yep.
I'm there. That took me a minute.
Okay, so then we just multiply that by 122, right? So we go 0.06 times, actually, I'm just going to steal this guy. Not steal, I'm borrowing it. Oops, maybe. What do you guys get?
0.00099.
If you multiply it 0.06
Oh, multiply.
times, yeah.
Okay.
7.32.
Okay, so now if I wanted to calculate, since I know that this guy's limiting, this is the one I'm going to use to calculate how much SB I'm making, right? So I can come back to this number here, that 1.5 moles of I2. We know the mole-to-mole ratio of I to SB is going to be the same that we have here. So it'll be 3 moles of I2, 2 moles of SB I3. And how do I calculate the mass of SBI3? It's ugly.
You're asking what's needed, right?
We're calculating, they want to also know, calculate the mass of,
I mean, like for the volume equation, you still need 2 more parts of it, right?
yeah,
Well, so wouldn't like it be?
I need one more part because I have moles, starting off with moles of I2, dividing it by moles
By 2.
of I2. So then that's going to cancel out. So I'm left with moles of SBI3. So how do I calculate the mass?
Gonna be 122 plus 250. SB is 122. Then iodine is 126.9 times 3.
So if I did my math right, 503 grams per. So you're saying multiply by the molar mass. Is that you're telling me, Iberi? Is that what you're saying, Iberi?
Yeah, the molar mass
Okay.
over 1 mole of SBI.
Okay. So I got 503 for the molar mass of SBI3. So then that's going to just be 503 grams of SBI3. Piece of cake?
Yeah.
I think this class has made me drink way more.
See, you're experiencing chemistry a different way.
Yeah, exactly.
Okay, questions? Everybody got that down?
Yes.
Oh yeah, hold on.
Are we going to talk about the lab, the balloon lab at all?
Yeah, real quick. It'll take you a minute.
Okay.
Megan, why do you have a smile on your face?
Happy as the last class. 5 more minutes of this and then done.
We're good. I'm good.
Okay, everybody good?
Yeah.
Okay, good. Okay.
No.
Wait, hold on.
It's already 6:30.
I'm tapped.
Been kept for the last 2 weeks.
Okay. Okay, let's see. I think we're gonna stop here. How about that?
Stop there.
Yeah, we're gonna stop here.